line is wrapped around many times in a helical structure. And when you have highly twisted magnetic field lines, it carries a lot of stored free magnetic energy, and sometimes it will even kink in on itself, which gives it even more stored magnetic free energy.
These plasma prominences can last for weeks or months, but eventually the stored up energy has to be released, and the mass is flung off into space. Where the sun's magnetic field is at its most twisted and complex, heat bubbling up from below is capped, and the material is cooled by as much as 1,000 degrees. What results are relatively dark blemishes on the solar surface called sunspots. Sunspots are only dark in relation to the bright material around them. If you could somehow suspend one alone up in space, it would shine 10 times brighter than the full moon. These apparently tiny blemishes are actually plasma craters the size of the entire Earth. Galileo was one of the first modern scientists to observe sunspots. Using a telescope, he projected an image of the sun onto paper and traced it. He realized that the blemishes were moving across the face of the star, which was the first indication that the sun rotated. Not only does the sun rotate, but sunspots themselves can actually spin like hurricanes on the solar surface. And when they do, their magnetic field lines become extremely twisted. Twisted magnetic field lines mean more energy, and more energy means the potential for huge eruptions.
Think of a rubber band as a magnetic field line. If you twist it, and you twist it enough, it's going to have all that energy, and when you let it go, it's going to release. If you just take an untwisted rubber band and release it, it's not going to fly.
When a sunspot unleashes its magnetic energy, what results are the most colossal explosions in the solar system: solar flares. A single flare releases as much as 1 billion megatons of energy, the combined power of 1 million volcanic eruptions on Earth.
They appear as these very bright regions, and they're so bright because the temperature is so high, on the order of 10 million degrees. And they can last for hours, but the energy is massive.
The whole explosion is equivalent to millions of nuclear bombs leaving the surface of the sun all at once.
Solar flares don't just explode out into space. They also funnel high-energy particles down to a layer of the sun called the chromosphere, where they quickly transfer their energy like a cue ball striking the rack in a game of billiards.
So the cue ball acts like one of these very high-energetic particles coming from the flare region. The cue ball smacks very quickly into the 8-ball rack. And once it impacts that head ball, it's going to transfer that energy to the balls behind it, and then they will all fly out because the energy is transferred to all of them.
If a large flare shoots enough high-energy particles at once, strange things start to happen. This is actual footage of a sunquake.
In 1998, there was a solar flare up in the corona that was so powerful that the material flying down toward the surface of the sun actually slapped the surface and caused ripples to spread out from there.
While they may look like ripples on a pond, these are actually waves 2 miles high, traveling at a maximum velocity of 250,000 miles per hour. The 1998 sunquake would have measured an 11.3 on the Richter scale, more than 1 million times stronger than the 1989 earthquake that shook San Francisco. In order to shake the surface of the sun that much, the solar flare had to release a colossal amount of energy.
It turns out it's almost the same amount of energy as if you covered the entire landmass of the Earth with dynamite, about a yard thick, and set it all off at once. So these explosions are not small.
Earthquakes aren't the only natural disasters with equivalents on the sun. A flare can also kick off a solar tsunami, as waves of plasma in the sun's atmosphere rocket out at 700,000 miles per hour, spreading around the entire face of the star in a matter of hours. While sunquakes and solar tsunamis pose no danger to Earth, the violent action of a flare frequently triggers dangerous eruptions called coronal mass ejections, or CMEs. In a CME, energy from a flare flings a blob of highly charged radioactive plasma out of the solar atmosphere.
Coronal mass ejections range in speeds, but they can occur as quick as 800, 900 miles per second, which is extremely fast, and they expel a massive amount of material. It can be the same amount of mass as, say, Mount Everest coming out from the sun and flying out into space.
Where does this blob of superheated radioactive plasma go when it leaves the sun? Sometimes it sails out harmlessly into space. Other times, it may head closer to home. Coronal mass ejections from the sun are perhaps the most dangerous threat you've never heard of. Also known as solar storms, they hurl large masses of supercharged particles across 93 million miles of space. Most take several days to travel from the sun to the Earth, but some rocket across the solar system at up to 6 million miles an hour, reaching our planet in less than 16 hours. These storms can induce currents in the outer atmosphere, knocking out satellites and cross-country power grids, and carry the potential to wreak just as much havoc on our infrastructure as a hurricane or tornado. But who on Earth is keeping an eye on these potentially hazardous cosmic blasts?